cool about proofwriting is I think that when people write their proofs, you see their personalities. So I try to find someone whose personality is quite different from mine in the department and ask them to write, just here, write this proof. And I gave them the same conditions, like suppose F is 1 to 1 and onto, prove that F is invertible. And when he wrote it up, I see his personality in that proof. So you'll find that my personality is in this proof. You see me adding color. I'm extrovert. You can just kind of see that coming out of the proof. I've noticed that people who are really like serious and bookish, they like to look up things, their proofs look like that. They're really square. So you see like different people's style is different. I tend to be less verbose actually, and I tend to have things boxed and numbered. I probably even did it. Yeah, you see I number things. So you see that difference. Let me pull up his proof, and Jake, you won't have that because it's not in Dropbox. I don't have internet, so I can't access it. But if you go to block 2 PowerPoints, I don't think I have it there yet. It's supposed to be here. Well, I know where I can get it from. Mailed it to myself. All right, let's take a look at someone else's proof. So one of the classes I taught at Montclair was I called it Math for Poets. And in that class, students, I had them write proofs because it was a writing requirement. So we had ways that we were going to get them to write. And it turned out that this class was a writing assignment class. I think someone in here said they want to go into teaching. So what was interesting, I gave the first writing assignment, and students copied everything literally from the internet and then gave it back to me. Like I could just put it in Google and it would come back up. So I quit doing writing assignments and I would ask them to do simple small proofs. And you can see on Rate My Professors, they say, well, it wasn't real math. Loved this class, it wasn't real math. And I thought, wow, they just were so innocent. And you would get these proofs where people would write in their own way. Really, you didn't have any math language in it because they were probably the opposite of a STEM major. They just didn't want to have anything to do with math ever again. So they didn't use any notation. You would have just a huge difference in how they explain things. But the bottom line is when you take something like this. So, for example, in this proof right here, he assumes that f of s is 1 to 1 and not 2, and he writes down show that there exists and he writes down the same thing, the definition of what it means to be invertible, which means that there exists a function g such. Notice that there's no notation, there's no f inverse because it's not defined yet. After it's defined, we call it f inverse. So right now he's calling it a g. He says an f is onto. Well, look, he went right back to the definition of onto that I showed you. That's the classic first definition of onto. That if for every y there exists an f such f of x equals y, we can consider the definition of g as g of x. So other than like me, I said it was a math. So it like I don't have to worry about it being a function or not. I just don't call it a math. But he said I'm going to consider informally a definition of g dy equals x, which we now need to show is well defined. So he took a different writing approach to me. And then he put in there what it means for g to be well defined. I didn't do that, right? I did something different. I wrote out in words that this map that I've defined may have two things it goes back to. I literally wrote that out. But he said, I'm going to prove to you g is a function. I think you did that too, Jake. You've proven g is a function, which is good to have in common with him. It's really smart guy. So then, so that's the definition of well-defined. He writes it out, that definition of well-defined. And now he's going to show you it's well-defined. So let x1 and x, let y be an AB, so that g of y equals x1. Now the structure is the same as mine, but he's going back to his definition of well-defined and pulling it back there. And he said he constructed the inverse. Do you see something else that's different from mine?
I mean, we really walk through like showing that f of g of x equals g of x.
Right, I actually put it in and actually showed it, but he's pointing out to you that he's defined it that way. So he skipped those details, thinking that the reader can go back and read that. It's really rare that I'm more verbose than someone else. Usually when I've looked at my proofs in comparison to someone else, I usually have less detail. Question, Jay?
Why did you do y in the interval, the closed interval A?
Because it's an interval. I think it was told to you at the beginning that it's an interval. Right, I told him that I gave you guys I as an interval and the real numbers. But these weird examples, this proof is not dependent on it being an interval, it's not dependent on B and R, and it's not even dependent on it being I to I. It could be dihedral group to the two-string break group. It could be from one topology to another topology. It could be completely different. And I can get some more, but you can see, I'll tell you who this is. This is Dr. Allen. Every time we've talked together, I think, wow, he's really different than me. I think, to me, he's a much more careful mathematician than I am. I'm the sloppiest mathematician there is. I'm on the low end for being tight and rigorous. He's very careful. And you can see that in his personality there. He's very careful about his mathematics. He knows the definition of well-defined. He's put it here and let you know that that's the definition. And that's what he's trying to prove. No color. Not that type. Okay, any questions about this? I'll find other ones that are smaller to bite off like this. These are like smaller proofs, but I'll give you stuff like that. And you're certainly welcome to bring in things from other classes and say, we were looking at this, can we redo it or reconstruct it? Writing a proof is a skill. And so whatever you do in one class transfers to another. So you're welcome to take, you have plenty of them. She's in every proof writing class. Are you in topology too?
No.
Okay. Why did you take that one?